We are going to learn how to operate the Gavett Audio Recording Studio here at the University of Rochester. So we're going to start with the on-off switch for this room. Now it's important to know that the console and the bay back here stay on all the time. Those two areas of the room will constantly be powered, as well as the laptop and anything that's in this ISO box for the computer. The power on-off switch for the room is located on the wall over here. The bays are going to power up in sequence, as well as our 3 sets of audio monitors. So here it is going on. Green light turns on. First it will be bay 1, then bay 2 will power on, then bay 3 will power on. The Genelecs will give a pop when they turn on. That's fine, that's a protection circuit. Then we'll see the power on the Focals, and we don't see any power lights for the Yamaha. The reason why that is done is to protect the loudspeakers. That's the ultimate goal. We do not want the speakers to get a loud pop from an audio surge that may happen while we're not here. When you're done with your session, you then hit the on-off switch again. It powers everything down in reverse sequence. Standing in front of the API 1608-2 console. I tried to clean all this yesterday, vacuumed, and accidentally sucked up one of the buttons. So I had to empty out the vacuum. I was out in the hallway like digging through dust, like, oh, there it is. Yeah, it was a fun afternoon. So an important step of approaching a console is making sure that the console is normalized. What normalizing the console is resetting it to a basic standard and just a blank slate. And that is for the next engineer that comes in. It's not for you, it's etiquette for the next engineer that walks in through the door. And so we can see right now that this console is not normalized. Okay, faders are everywhere, there's buttons lit up. All of that needs to be off. All the knobs are kind of turned in different directions. And so I'm going to show you real quick. Channel 1 is non-normalized. We see buttons, we see knobs that are turned in all directions, and we need it to be normalized. And what normalized means is channel 2. Fader is down, there's no lights on, all the buttons are up and not lit, all the fader knobs are turned down or set center depending on what types of knobs they are. So like a pan button or a pan pot will be set center instead of left or right. But we can see the difference between a non-normaled and a normaled channel strip. So let's walk through the process of normalization. So let's start with that channel 1. First I'd drop the fader, I'd unmute everything, and I'd turn all these down. The aux sends 1 and 2 must be all the way to the left, 3 and 4 all the way to the left. But aux sends 5, 6, and 7, 8 are a little bit different. The top knob is a level knob, so we want to turn that all the way down on both of them. But the bottom knob, these are concentric knobs, that means they're stacked. The bottom knob needs to be center because it's a pan knob. We can kind of see that with this graphic image that says pan and level. So the top knob is level, bottom knob is pan. So we want that top knob all the way down. We want the center knob center. Then we move up to the pan, and then all lights are off. And so we continue that every channel that we see. So we need to turn that knob down, we need to turn those down. And this is just a nice little thing to do at the end of the day. Your session is finished, you put on some music, something that's not really abrasive. It's the end of the day, I'm tired of listening to things, and so what I'm going to do is put on some good music that I enjoy, and then normal the console as I go. And you get really quick at this. You start to just eyeball it. You start to realize like, oh, this is pretty easy and kind of soothing. But that's the process of normalizing a console, and you are expected to do it at the end of all of your sessions. Label tape. All right, one of the critical things about running a recording session is knowing what each channel is assigned to. And part of that is using board labeling tape. It's a special kind of tape that's not going to leave any sort of residue on the desk. We can write with it using a Sharpie. Please don't use the Expo board markers because it will rub off on your hand and you'll lose anything you wrote. So please use the Sharpies that are provided. We take the labeling tape as one big piece and we run it across the top of the faders. Tear it off. Some engineers like to run the tape below the faders, so they'd go along here instead. I tend to find that my wrists will start to rub off even the Sharpie. So that's just me. I'd rather be above the faders, and also it's more in my visual field as I'm looking at the console and the on-screen monitors. I say what the session is, and I usually put the date. So we're going to be mixing and setting up a jazz trio. Today is July 18th, so I'll put 07, 18, 23. And then usually on the right side of my master fader, I will put my initials so that I know that this is my board labeling tape, because we can reuse this. So our Pro Tools session up here, this kind of mirrors exactly what we're going to do. We can look and see our output 1, output 2, output 3. That's going to go to output 1 on the console, output 2 on the console, output 3. And so now we can look and see what these are labeled. Kick, snare top, snare bottom, rack, floor, overhead left, overhead right. So I have 1, 2, 3, 4, 5, 6, 7 drums. So I'm going to split up all those, 1 through 7. And I usually like to do what's called kind of a split thing, where then I have kick, snare top, snare bottom, rack, floor, and then my overheads, overhead right, and then I just put drums down here. So now I know that between these two solid lines, those are my drums. If we move on down the line, we see that there's bass DI and bass DI overdub. We're going to have 2 channels for bass. So again, solid line, channels 8 and 9 will be bass, and we have 1 DI, and then we have an overdub. And so you just move through and make sure that anything that you have up there on your mix window matches exactly your outputs to the console. And we continue labeling until we're done. Now that we have things labeled, we have something playing back in Pro Tools, it's time to make some noise. I'm going to bring up this ribbon microphone that's on the trumpet. Now, in order to do that on this console, there are 10 buttons and faders that have to be on in order for that to happen. First one is your master fader. This needs to be up. Just throw that up to 0. You need to make sure that your PGM bus on your control room source is lit up. PGM. That means program, and that's your program bus. You need to turn your control room left and right on. We need to make sure that the program RT, program right, is on. We don't need to touch this knob. That remains always at 12 o'clock. Same with this knob, but program left needs to be on. Then we jump over from our master control section over to the channel that we need to hear sound from. We need to turn up the fader for that channel, and we need to assign it to the program bus. So we need to turn that on there. We can see that I'm getting signal on my VU meter for channel 10, which is my ribbon microphone of the trumpet, but we're not hearing anything. The last step is control room main source knob, which we can see is rubbed off, but that's used to say control room. And we have audio. Now you may ask, what if I forget one of those steps, right? There's 10 buttons I gotta remember. Well, if you turn the fader down, no sound. If you forget to hit the program button at the top of this channel, if I turn that off, no sound. Back in. If we come over here and we turn down the master fader, no sound. If I turn down my control room volume, no sound. If I turn off my program left and right, no sound. If I turn off my control room left and right, no sound. And if my control room source is set to anything else besides PGM, no sound. And we can also choose what speaker system we want to listen to. The main speakers being the Genelecs, Alt 1 being the Focals, Alt 2 are the Yamahas. So when I'm playing back from Pro Tools or Logic, these are the 10 buttons that I need to use in order to get sound through this system. Let's make some noise. So what if you wanted to listen to something that wasn't Pro Tools or Logic? Say you want to listen to Spotify and you're just kind of hanging out, or Tidal, or check a YouTube video or something like that. You can do that within the system, and it's all built in and hardwired, but it's just a sequence of buttons that you have to hit in proper order. We have it in PGM because we were working with Pro Tools or Logic. But now I want to listen to just the output of the computer. That's going to come back on 6-track Playback 1. So if I hit that button and then turn up my control room knob, from there we can choose whatever speaker monitors we want to choose, from main speaker to Alt 1 to Alt 2. But it's also an important thing to notice that we have sound here. I don't have a master fader up, because the master fader is part of the program. It's part of the summing of this entire console. And since we're just coming from the computer, it's just a source. It's like plugging in your laptop into a loudspeaker in your dorm room. Another important thing to notice is that because we're not using our program, if you're just playing back from Spotify or Tidal, we don't need those two buttons, program left or right. But we do need control room left and right on. If we turn those off, we will not hear anything playback from the computer in the studio. Okay, for this next section, you got to stick with me. There's a lot of buttons and knobs on this console. I'm going to go through a channel strip and explain how it works. But there's some things that I cannot go into detail just yet. So at the points in this where I say skip ahead, don't skip ahead just yet. Stick with me until it's done, then go ahead and find out more about the summing bus or the auxiliary bus sections. We're going to talk about the 548C channel strip, every button. We are going to ignore a lot of the EQ section up here, so in your visual field, you're mainly seeing from the top of these channels down to about where the faders are. But we're going to focus on what's called the 548C channel strip. So at the very top, we see buttons, 1, 2, 3, 4, 5, 6, 7, 8. They are numbered. There's another button here that says pan. This section is delineated by a kind of white line that's zagging through those buttons. This is your summing bus section. Basically, when we engage these buttons, they send the signal somewhere else. They split the signal at this section, and we send it to summing bus 1, to summing bus 2, 3, 4, 5, 6, 7, 8. We still get the signal coming through the channel, but it splits it out so that we can use it elsewhere in the console. I'm going to refer you to later on in this video when I talk about summing bus routing, where you can actually hear audio examples of why we use this. The pan button here does not actually engage the pan knob. What it does is it tells me if I have this engaged and I pan my knob to the left, it's going to only engage the odd numbers in my summing bus. If it's in the center, it will send to both 1 and 2 equally. If it's over to the right, it will only send to, again, that's only if this pan button is engaged. If that pan button is not engaged, it will send to both 1 and 2 equally, or 3 and 4 equally. Moving down, we see that we have a pan knob. Most of you are familiar with what a pan does, using Logic, using Pro Tools, or Fruity Loops, or whatever DAW you may use at home. Basically, it sends a signal to the left or right by using gain. The program bus assignment switch. This assigns the channel to the master program bus, meaning your master fader. So it's where everything sums together. So in order to send this and mix it properly, that needs to be on. The pan knob is pretty self-explanatory. If any of you have used any sort of DAW, Pro Tools, Fruity Loops, or Ableton Live, you should know what a pan knob. It basically is a gain that changes your gain from left to right or anywhere in between. The filter button over here, this is a high-pass EQ filter, which basically lops off any audio below 50 Hertz with a 12 dB slope. The INS button is the insert return button. Please refer to the chapter in this video about the patch bay to learn what the insert return does. The next section are all the green knobs. This is your auxiliary send section. So we have a difference between summing bus sends and auxiliary bus sends, and there's a section of this video detailing that. So please refer to that for any questions regarding that. But your auxiliary sends are labeled 1, 2, 3, 4, 5 and 6, and 7 and 8. And you can see that 1, 2, 3, 4 are separate mono channels. So they each have individual control. If I engage channel 1, that's the top knob here. If I engage channel 2, that's the bottom knob. These are known as concentric potentiometers or concentric knobs. And we can see on this little graph here, which is labeled 1 and 2. 3 and 4 is the same way. They are both mono, 3 on top, 4 on bottom. 5 and 6 and 7 and 8 are a little bit different. They are stereo aux returns. So they have 5 and 6 together, and the gain is on 1, or is on the top knob. The gain is on the top knob, and then pan is on the bottom knob. So if we want to send only to 5, we turn up our volume and we pan it left. If we want to send only to 6, we pan it right. And if we leave it center, it sends to both 5 and 6 or 7, 8 equally. There is a 2 bus button that is going to send this to my summing bus. Now you notice pre buttons on all of these. This means pre-fader or post-fader. Please see the section of the video that has more detail on the pre and post-fader operation. The next section is my preamp section, both for my line level and my microphone level. In order to get audio from a microphone, we need to engage the mic preamp. Currently, it is in line input because no buttons are highlighted. But once we hit mic, that means it's now switched to the mic preamp, which engages this knob. This knob is a mic pre-gain, which goes from 0 to plus 55 decibels of gain. The button above it is a phase flip button. That basically flips the phase relationship of the mic preamp from 0 to 180 degrees. This is useful when miking the top and bottom of a snare, is the best example that I use in class. If you have 2 microphones, let's say our top snare is on channel 1 and our bottom snare is on channel 2, we need to flip the phase of the bottom microphone in order for them to be in phase together because they're pointing at 2 different angles. The pad is a decibel pad. When it's in microphone preamp, that is a 20 decibel pad. It will knock down the decibels by 20 dB. So if you have a very loud source like a kick drum, you may need to engage the pad in order to prevent distortion. If it is in line input, this pad is at -6 dB pad. So the difference of the pad depends on whether you are in mic or line. 48 volts is your phantom power, and that is used to power condenser microphones. So anytime you have a condenser microphone, you need to have 48 volts selected. Do not use 48 volts for ribbon microphones, it can damage them. But you can use it or forget to use it for dynamic microphones, it won't harm them. We come to the last 4 buttons of the channel strip. Number 1, this is my mute. So the number that indicates the channel is also your mute button. So that mutes the channel. Above that is solo. That will solo the channel. Sometimes it takes a little while to stick. And that will solo that channel for you. Next to that is safe. Now, in certain configurations of how this console is set up, there's something called solo in place, or SIP. There's a button for it further down the console. And when solo in place is activated, and I hit solo, we see that all the other buttons, or all the other channels get muted automatically. So what safe is going to do, now keep an eye on channel 2, what the safe button is going to do is it's going to mark it safe where it won't mute that channel. Okay, so even if I hit solo on another channel, it will keep number 2 safe because I have safe engaged. But that's only in solo in place. If I take that SIP button off, which is further down the console in your master section, everything returns to normal and the safe button doesn't do anything. The mute group button, when I engage that, what I can do is mute certain channels together. So I'll mute 1, 2, and 4 together, but not 3. And further down the section, in the center section, there is a mute group button. And when I hit that, anything with mute group has mutes on them now. If I take it off mute group, it will not mute that. So why is that useful? That's useful if, say, hey, I have my drums right here, kick, snare, snare, and rack tom, okay? So maybe there's a section where you recorded drums and you want to mute all the drums at the exact same time. Like there's a big break in the song and you need to mute all the drums. Well, you can sit here and try to do that, and sometimes it's gonna work, and try to time it, or you can have all your mute groups and you just hit the mute group button and it mutes them all together.
Good job.
Thanks. We're going to talk about the 265C aux bus master and stereo return sections. Continuing our button by button journey, these 8 green knobs and their associated buttons around them have no bearing on everything below this heavy white line. These stereo returns are a separate function from these 8 aux send masters. So we have on channel 1, 2, 3, 4, 5, 6, 7, 8, a green gain knob, and that is just your gain, much like a fader would be on any console or DAW. In order to engage any of these, we need to turn them on. That's simply what the on button is. It's going to turn that master aux send on. The VU button is going to send this so you can visually see it on the console in a VU meter. Does not always need to be on, but it's there for your reference if you need it. The external in, don't worry about that. You're never going to use it. I might, and when you get more advanced in this class, you might want to use it and learn what it does. But honestly, for the purposes of AME 192, you don't really need to know that. Talkback is important, TB, T/B. This is to assign my talkback so that I can talk to musicians. Usually I assign this on one channel, and usually I go with channel 8, the last channel. And I just say, this is my talkback channel. I don't put any other music through it, no instruments, nothing else. This is just for me to talk back to the musicians. You don't want to assign talkback to every single one like that, because then you're going to blow out their ears every time you talk to them, because essentially you're going to replicate the gain over and over again. So choose one talkback and they can hear what you're trying to say. And lastly is just the solo button. And that just works just like any other solo button on the console. It's going to solo that aux send master. The next section we're going to talk about button by button is the stereo return section. And what that does is these are returns back from either within the console or outside the console. So say we want to bring a reverb back into the console that we use in outboard gear. Well, we can send it out using auxiliary sends or summing bus sends, but we need to bring it back into the console so that we can mix it correctly. When we want to do that, we can use stereo returns rather than using up channels. When we insert a reverb or something like that, we can bring it in and we can solo that. We can mute it much like we do a channel on R1, R2, R3, R4. We have 4 stereo returns. 7 and 8, this button, what it does is it sends it to summing bus 7 and 8. The safe button works much like the safe button that we used in the channel strip explanation. PGM, yeah, we already know what that does. That's going to assign it to our program bus so that we can hear it. The auxiliary in is a little bit different. In using your patch bay, you can use an auxiliary in through your stereo return. The 500 inserts we will talk about in about 2 seconds. Mono is going to sum the stereo into mono, and then insert is another insert point which we can engage through the patch bay. Going back a few steps, so we left off with insert, but going back to 500 insert. Why is there a difference between 500 insert and insert? Well, it has to do with these 3 units up here. So if I hit 500 insert on return 1, this is the 500 insert for return 1. So it's going to engage this compressor, which is the API 529 compressor. If I hit the 500 insert for return 2, it's going to hit the Shadow Hills compressor. Return 3 is the Elysia character distortion unit. And on return 4, 500 insert won't work because there's nothing here. Now we're going to talk about the 168C summing bus module section. This strip here, the 168C summing bus master module, and this is tied into your summing bus assignment section for each channel. So number 2 here is going to be mapped to bus number 2. Likewise, number 5 will be mapped to bus master number 5. We have an on button, that's to turn on that summing bus. We have a gain knob, Gain goes from -infinity to 0, all the way up to the top. We have a solo button, and then we have our program right and left assignment buttons. So that's going to send it to your master program. And that's it. And there's 8 of those, and they all do pretty much the same thing. Up next, the 268C monitor output master section. We've already gone over most of this operation in the 10 buttons you need to know about how to get sound through the console. Basically, they're assignment buttons. These 4 buttons up here have to do with turning on surround speakers. We don't have a surround system in this studio, so you'll never need to turn those buttons on. You do need to engage the control room left and right to turn on your monitors. All these little trim pots that are in here, you don't need to touch those. Those are for me and me only to adjust audio. I'm going to jump and skip over program insert at this time and just jump down to what we already know, which is the program left, program right. We know that those need to be on in order to hear your summing program of your mix. These trim knobs above are very, very fine-tuned trims. And so what those are going to do are very slightly turn up the volume or turn down the volume. These should be calibrated, and you should never need to turn those knobs. Now back up to your program insert. The program insert is a button that if you want to patch something in to your program that is not contained within your console. So say you want to patch your phone in hardwired through the program, you would use a cable to go into the patch bay, into the program insert, and then you would engage this button. But if this button is engaged and you're trying to hear Pro Tools, you will not hear it because it is essentially a bypass switch. It will basically override what you're trying to sum together in your console. So this button generally is always up. Continuing our journey on the console, we have the 845C monitor controller section. And we're going to start with just the control room source, which is this white line and above. We already know what the program button does, and we know what 6-track Playback 1 does. That's going to get us Spotify or Tidal or whatever we want to play through the computer. But we haven't touched everything else. So program is our program summing bus. Our aux sends, this is so we can listen to what's going on in those green knobs, all those green sections up there. We can actually listen to those to see what is actually being sent to them. And that's what those are. Those will select those. The 6-track Playback 1, 2, and 3 are for sources outside the console. We already know that 1 is for the computer, the main computer in the room. 2 is for a laptop connection. So when I'm teaching you in class, this is what I'm using so that you can hear back from my laptop. And 3 has nothing on it. The bottom section of the 845C has to do with how we listen to our audio. We already know what the control room main knob does. This adjusts your volume. As I've taught you in class, once you set this volume to around 85 decibels, you don't want to move it a lot. But what if you need to dim the audio just a little bit to hear some people talking in the room or have a discussion with the band that you're working with? You don't want to constantly be turning this up and down. You want to set it and forget it. So in order to dim things, we use the dim button. The dimming switch is an engaging switch, and we have a separate dim level tied to it. And what that's going to do is dim all the audio so that you can have a conversation without losing your main set audio in your control room volume. We hit that dim switch, we can adjust that level to whatever volume we want, but we maintain our decibel level at our main volume. We have our main speaker, Alt 1 and Alt 2. We've gone over these before, but for a refresher, the main speaker are the big Genelecs, the far field speakers in the room. The Alt 1 are the Focal near field speakers, and Alt 2 are your Yamaha NS10s. The cut button cuts all audio no matter what is going through the console. So if you have a major feedback issue, hit the cut button. Don't let that come through the console and come through the speakers. I usually like to engage cut at the end of my session to just basically reassure that no audio is ever going to go through my console while nobody's here, but that's optional for you. But I like to do it, so I recommend that you do too. And then the mono button is a mono summing button. And this is to take your stereo field and sum it down to a mono mix. When we talk in class about mixing and approaches to mixing, a lot of engineers like to mix starting off in mono and then go to stereo. Think of Derek Ali, who mixes a lot of Kendrick Lamar's stuff. Starts on mono, goes to stereo. So this is a summing of the two stereo channels to mono, and then if you unengage that, then it goes back to stereo. And finally, we're going to talk about the 840C multifunction module. It's called a multifunction module because really none of these things have any bearing on each other. They do control other things and functions within the console itself, but within this strip, they're not talking to each other. They're not friends. First up is the oscillator. An oscillator is just a sine wave generated tone internal to the console. We can change the frequency of that tone, we can change the volume of that tone, we can assign it to that bus, and we can turn it on. This is useful when aligning gear outside of the console, such as a tape machine, but in general, you're probably never going to use it in this class. The peak threshold knob here is a singular knob that varies the threshold of your peak light on each channel. So as I turn this down, we start to see some peaking happening. And this is to alert us that there may be some distortion. If it says all the way down, we have a peak light that's pretty much constantly lit, saying that there could be a large chance for distortion. So you may ask why you need a variable peak threshold knob. Well, it's pretty easy. If you're recording classical or jazz, you want to know distortions happening as soon as they happen. So you want to set this all the way to the left, +4. But if you're working in rock, pop, hip hop, even modern country, you can go all the way to +24 because sometimes we like a little bit of harmonic distortion. Next up on the 840C is the global channel controls. And what we see is VU CH and VU bus. This is going to tell me what I'm monitoring on my VU meters on the console. VU channel has 2 modes, and you can see these lights light up as they change, as I hit it. So it'll either be in mic line or in direct input, and you can monitor either one. If it's in VU bus, that means we're going to monitor our buses on the VUs. 0 dB bypass is a button that makes all the faders on every channel go exactly to 0, even if the faders are down. So this is a way to get audio through if you want to mix completely in the box and not use the console at all. You can use 0 dB bypass to guarantee that all your faders are at exactly 0. Mute group we went over earlier when I talked about the 548C channel function module. And so refer to that part of the video to learn what mute group does. All right, for the next section of the 840C, we had to pan the camera over just so it makes a little more sense to you all. This is our solo master section. Here we have a level knob to decide how loud the solo should be when we solo a channel. So if I solo channel 17, we see the solo clear light up, and this will change the volume of that solo. Solo clear is lit up, and so if I have 2 channels soloed, or no matter how many channels are soloed, we hit solo clear, it cancels out all my solos on the console. We have 2 other buttons, solo in place, SIP, and after fader listen, AFL. Solo in place, when engaged, if I hit solo on channel 17, it mutes all the other channels on the console. If I solo channel 18, it unmutes it and it keeps it as part of the solos. Once I hit solo clear, it all goes back to normal. That's solo in place. After fader listen engages after the fader. So we're going to listen to the solo at the volume of the fader of that channel. So we're going to listen to the solo at the volume of whatever this is set at. And that's what that is. If this after fader listen is not engaged, our solo level is going to be tied to this level and has no bearing on the fader of the channel. Next is the talkback section of the 840C multifunction module. We can choose to talk back to our buses with a separate volume. We can talk back to the auxes with a separate volume for that. Or we can talk back to all, which will send to both the buses and the auxes. You may ask yourself, why not just hit talkback all the time? Or why are there 2 separate ones? Well, when we talk back to aux, we're generally talking back to the musicians in the other room. If we want to talk back to the bus, that's usually your slate. So you can record yourself saying, this is a really good take, and the musicians won't hear you. Or this is a really terrible take, and the musicians won't hear you. If you hit talk back to all and you say, this is a really terrible take, most of the musicians are going to stop playing. It's good to note that the talkback microphone is located on the console above the Elysia character 500. The last button and knob on this console that we're going to go over today is the 840C headphones. This is your headphones. This has no bearing on the musician's headphones. And that's why we discern between a cue system for the musicians and the headphones for us. This turns on headphones for you if you need to use headphones with an associated volume or gain knob. The headphone jack for you is located underneath the desk, right about where you're sitting currently. We are going to discuss how to get audio to your cue system. Now, what is your cue system? Well, it's your musician's headphones. The reason why we say cue system rather than headphones is to discern between your headphones and the musician's headphones. In order to get sound from the console to the cue system, we use our aux sends, which are all the green knobs for each channel. The aux sends can be used to send varying amounts of different instruments or different microphones through the cue system for the musicians to listen to on headphones. So I'm going to show you in one example, just using the trumpet that we were using earlier. I'm just going to bring in some trumpet here. We can see that the audio is coming through on channel 16. We're getting it to our program, VU, and we're obviously hearing it at this point. So we're going to start with sending it to aux 1. So we need to engage aux 1, and we need to turn up the gain for aux 1 on that channel. So we're going to turn that knob up. This is then sending the signal from here to our aux send master. We need to turn that on and also up. And now we should be able to see that in our cue system. There's a little 0. That's your nominal value. So usually I start off with just turning my gain to 0, and that's where I want it to be. Now, with this engaged on channel 1, now I got to turn my gain up here, which is my knob for channel 1, gain for aux send 1. So the audio is being sent from here to here, and then finally out to the cue system, which is located over here. And we see on channel 1 of the cue system, our audio level is showing up. And notice that if I turn down the gain of the aux send, it turns it off. If I turn down the gain of just the channel aux send, it turns it off. And if I turn down my fader, it turns it off. There's one added button, and this is called pre or post fader, which is very important. All of our auxes can be sent either pre or post fader. When I move this fader down, it stops sending audio to that cue. If I engage this pre, that means it's pre-fader. So it's like splitting off the signal before it reaches this fader. I can move this fader all day long, and it's not going to affect my cue mix. So as I'm doing this, you can look down there and see that you can hear me sliding that fader up and down. And you can see that is not changing that green light. Why would you want to do something pre or post fader? Well, say you have musicians and they have a cue mix set up and it sounds really good and balanced with them. If you have this in post fader and you're in here doing your own mix and you adjust this volume, they're going to lose that instrument. They're going to lose that feed. So anytime you're recording, I would always have my cue send sent to pre-fader. That way you can make adjustments all day long and it's not going to affect the musician's performance and what they're hearing in their headphones. You'd want to use post fader sometimes in mixing. You want to make sure that, like, if I use my aux sends instead of using for a cue mix and sending it out for a reverb or something like that, then I can use post fader because then I'm getting the right amount of blend of wet and dry signal. Make sure the musicians are getting everything pre-fader so that you can mess with all your faders as much as you want without affecting their mix while they're recording. So the example you just saw was a mono aux send using just aux 1, going to the aux send master for aux 1, and then we ended up on channel 1 of the cue mix. What if you want to use a stereo aux? So the stereo auxes are 5, 6, and 7, 8, and they're paired together as a stereo channel. Well, again, we'd come over here to our channel strip, and we'd engage 5, 6, and let's put it in pre because we want to do it in pre-fader. Because we're sending it to our musicians' headphones.
Will you start from we'd engage 5, 6?
Yep.
Okay, I'm ready.
So we'd engage 5, 6, And let's start it using pre-fader so that, we're not, I'm going to start again. So we're going to engage 5/6, and we're going to use pre-fader so we don't affect the musician's headphones and cue mixes. We need to turn up the gain, and currently it is sending to both 5 and 6 up here. So we have aux send masters 5 and 6, which again, we need to turn on for both of them and set those to 0, which is about 1 o'clock on the knobs. And now, if you go down and look at the cue mix and what's being sent, you will see that both 5 and 6 channels 5 and 6 are illuminating with the same audio signal. On this console, we have aux sends and summing bus sends. Now, what really is the difference between the two? They operate largely the same way. The aux sends on a channel, these green knobs, get sent to a master aux send, which then sends it essentially outside of the console. That signal gets pushed away from the console to be used for output gear or things like the cue system that is set up. The summing bus sends. Summing bus sends are these buttons up at the top of each channel strip that we discussed before. Those also, when engaged, then have to go to the summing bus masters, which is this strip over here of black knobs, and then that sends the signal outside of the console. Both of them do the same function. Now, why would we use one instead of the other? Well, auxiliary sends, as noted in the auxiliary send setup section for the cue system, can be put in pre or post fader. So they can be put in pre-fader, and I can move this fader all day long, and it doesn't affect my level sending out of the console. Summing buses are only post-fader. You cannot send them pre-fader. So that's going to affect how you then determine how to use these. So if I'm using them for a cue system, I'm probably going to use only auxiliary sends because I don't want to mess up any of the musicians' headphone mixes. If I'm sending to a compressor or a reverb or some other sort of external gear, summing buses, on the other hand, are only post-fader. And so if I want to send anything to a reverb or a compressor or anything like that, I can essentially choose whether I want to use summing bus outputs or auxiliary bus outputs. Both of them are going to do the same thing, which is effectively split the signal from the channel, send it outside of the console so that you can manipulate it using some kind of outboard gear. Essentially, both aux sends and summing bus sends achieve the same goal, which is to split the signal and send it out of the console so we can manipulate it elsewhere. It is up to you how you choose to use those sends. Again, there are preferred methods, whether you're using it as a cue system or for reverbs, compressors, or delays.
Okay, I'm ready.
So the aux sends here, then send to here, much like the summing bus sends here. These buttons up here will send to the summing bus masters here.
Yeah, let's just do that one more time just to make sure
A little bit
I have
slower.
it, but yeah,
Okay.
that was good.
The aux sends here on the channel will send to the aux masters here. And the summing bus buttons and assignments will be sent to the aux, or the summing bus
Sorry,
masters.
I missed that. Start again for the summing
Summing
bus.
bus.
Yeah.
And the summing bus assignment buttons will then send to the summing bus masters, which are located here. So when you're recording an ensemble, a really good idea to keep in mind when you're using an analog console is to use one side of the console for tracking. So this is where your microphones come in, and this is where you set your microphone levels in order to be recorded to Pro Tools, Logic, whatever DAW you're using. The other side of the console is then used for you to start mixing. And so you reflect that within your DAW. Your inputs will be channels on this console, 1 through 16 on all your channels in Pro Tools, all your tracks. And then your outputs of those same tracks will be 17 through 32. But if you're new to this console and new to this kind of approach to recording, you're going to end up putting the input and the output on the same channel. And problems can arise. And one of those problems is called a feedback loop. What a feedback loop is you have an input, which is then sending directly into an output, which is then sending directly into that input, and so forth. And it creates a loop. It's much like a snake eating itself. So I've set that up over here on channel 21. And anytime you start hearing feedback, the best thing you can do is cut your speakers. So that's why there's the cut button right in the center. And I want you to notice that in Pro Tools, the input and the output of Pro Tools are both 21. If I put this channel in program and send it to my master program and then hit record in Pro Tools, watch what happens within Pro Tools. That is known as a feedback loop. And if you hear that, what you need to do, first of all, is cut your monitors. That's why we have this cut button. My voltage unit meter, my VU meter, is being pinned on channel 21 because I'm having feedback problems here. The way you alleviate this immediately is I either take it out of record and it gets rid of that problem, or we take it out of sending it to our program bus, or we turn down our fader. Any of those things will help fix that. It's a feedback loop in the sense that we are sending our line out back into our line input, back into our line output, back into our line input, and so forth. And it just feeds and feeds and feeds, and it grew as we heard. We heard the feedback grow and grow and grow. And if you encounter that problem, the first thing you should do is cut your speakers because it can damage the speakers. And that's very bad, and they're very expensive to replace. And then you try to fix the problem from there. Now we need to address the real issue, which is that your input and your output in Pro Tools or Logic is exactly the same. You want to make sure that you don't do that. You want your input to be different from your output to make sure that you do not get a feedback loop. So we learned a little bit about stereo returns, and at least what those buttons were, right? So now we're going to learn to actually use them. And so what we're going to do is we're going to take our trumpet signal and we're going to send it out via a summing bus to a reverb unit that is external. We're not going to use any plugins or anything like that. We're going to actually use reverb outside that is hardware. We're going to bring that reverb sound back into the console using our stereo returns. So I'm going to play so we can hear at least what our dry signal sounds like. I'm going to use my dim function to dim it down, not touching my control room button. I'm going to send it to summing bus 1. I'm going to engage my summing bus master on, and I'm going to turn all the way up to 0, my nominal level. Now we have to move over to the patch bay. We are going to come out of summing bus output 1, and so now my signal is being sent. It's at the tip of this, and we're going to go into this piece of gear, the Lexicon PCM 92. And we can see that I'm getting signal. Even though I'm sending mono, I'm still going to get a stereo reverb. So I'm going to come out of the PCM 92. I'm going to come into stereo return input, 1 left and 1 right. So we're going to go into 1 left. I'm going to grab another patch cable, right, and then bring it into the right. So now I have it returned and input in the patch bay. And now we're going to walk back over to the console. We're going to put it in program, my stereo return. We're going to hit PGM. And now I have reverb. I can solo that reverb. And this is my dry. And that's how you get a signal out of the console to be used by a reverb or something like that and bring it back in.
Sick.
Yes.
Seriously.
Okay, what if I wanted to use a stereo return to use one of these hardwired to the console to those stereo returns, one of these 500 series racks. We're going to use the Elysia character distortion because it's really easy to hear what it's going to do to the sound when we bring it in. I have my trumpet, which I can hear. We're going to dim that now so that it's not loud while I'm talking to you. We're going to send it out on summing bus 3 this time. So we're going to use a different summing bus. We're going to make sure that our master summing bus is on and turned all the way up. And now I need to patch it. Again, I need to use the patch bay. So we're going to walk over to use the patch bay. And we're going to use summing bus output 3. And this is a really quick and easy patch. Now because the Elysia character is on stereo return 3, we're going to go into stereo return input 3. There's 3 left and 3 right. Since we're just using a mono signal, we only need to use the left. So we're going to come back over to the console. The Elysia character is coming directly into the return 3 here, but we need to engage it using 2 buttons. We need to hit the program button to assign it the program. So we're going to come back over to the Elysia character, which is our 500 series, which is matched to the return of 3 here. So our audio is playing. I'm going to undim it just to hear the dry. We need to assign this to our program. We also need to assign the 500 insert, which is going to activate this. And now when I take it out of dim, we're going to hear our dry signal. I'm going to slowly bring up this fader and you'll be able to hear the distortion that this is creating. Up next, we're going to talk about a patch bay. So a patch bay is like the central nervous system of the whole studio. All of the cabling, everything that can be sent anywhere, any sort of signal, runs through the patch bay. So it is very important to know and very important to learn. If you need extra help reading the patch bay, I've made this handy guide. This handy guide tells me what the pieces of gear are, along with their corresponding colors that match what's on the patch bay. So the overall picture of a patch bay looks like this. Starts at the top, works its way to the bottom. That's how the signal is flowing. The patch bay starts with all the microphones lines that are coming in to the studio. So this is all the microphone lines from the live rooms, from the mix rooms, from the hallway, all come in here. They then are automatically normaled to the inputs of the console up to channel 32 because we have 32 inputs on our console. Then those go out of the console directly into Pro Tools or Logic, into the computer, out of Pro Tools and Logic, back into the console, where you then mix. Anything below that point is kind of optional things that you can patch point to make a mix however you want and build it all up. More over here towards the right of the patch bay is most of our outboard gear. So all this multicolored stuff that you see, a lot of that is the pieces of gear that are in the bays that surround the console. When you get further down, we get into the summing bus outputs, the aux sends outputs, and some other parts of the console that then are normal to the headphone cue input. Over here we have our 4-track tape machines and some other pieces of gear. And then down here we have our final outputs, like our main program out, the output of the computer, the laptop output, and and going into your 6-track playbacks on the console. Now within the Gavett Studio here at the University of Rochester, you may notice that we don't have a window you can look through and see the musicians performing. Instead, we implement a camera network, a closed circuit camera network, which is controlled using this interface over here. We can turn on our displays within the room here, and they will turn on, and you can see that there are cameras in the live room, which is next door. We can change our video routing to be whatever we wish it to be. We have a camera above, which points down and looks at the console. We have an engineer camera, which is used for you to maintain visual contact with the students. And we can kind of see, this is Alex, my videographer and good friend, here with me today. We can also look at the output of the Mac Pro. So if you want to look at the Pro Tools on a bigger screen, we can put the Pro Tools up there from our computer. If you are on Studio cameras, so say we're using Studio 2 camera, we then go to camera control, and we can control the camera and its panning, as well as its zoom. We have full control and able to see into all our spaces that are here at the University of Rochester. So next we're going to talk about the Starbird stand. We use Starbird stands in audio engineering to hang heavy microphones or hang multiple microphones on one stand in order to get full length and extension over an orchestra or over a drum set. They're one of the most dangerous things in the studio because of this heavy, heavy counterweight at the bottom. So there's some precautions I'd like to go over with you on how to appropriately use the Starbird stand. First, we need to lock it. We need to lock those lovely casters to the ground so that this stand does not move. Secondly, I'm going to show you how far this actually extends up into our studio. Now our studio height, our ceiling height, is about 40 feet, a little bit less. We have pendulum lights that are hung from the ceiling, and you need to keep in mind that if you have this at full extension, it's going to run into those pendulum lights. So we'll start by extending just the first boom. And that's already pretty high. I can't dunk on that. Maybe you can. Then we're going to extend the second part of the boom by grabbing the bottom of the counterweight and pushing upwards. And it's not even full extension. We still have about 4 inches left here. But now we're going to extend it using the last part of the boom, which is the straight, and we're just going to let that go all the way up. And we can see it is extending past the lights by about 6 feet or so. It's pretty high up there. So this is the height of a Starbird stand. Very rarely are you going to need that kind of height on it, but now I need to pull it back down. I'm a pretty big guy. I like to think I'm pretty strong. It still takes most of my upper body strength to pull this down and get it back and locked into place. So once it's locked and tight, now we're going to drop this down, the second boom arm, tight, and the third boom arm. And we want to make sure we don't pinch our fingers there if we let it release too hard. Now, when you're actually using this stand appropriately, you need to balance it, and it's because of this heavy counterweight. So let's extend this first boom arm again to an arbitrary length. We're not going to go full extension. We're just going to kind of go a little bit high. I'm going to loosen the knob that controls the angle at which this is located at. And so you can see this is pretty heavy here, okay? Now, this is already loose, so I'm going to extend this out, but all my weight is still over here by the counterweight. I want to extend it as much as I can until I get a balance between either end. All of this is loose. If I push down a little bit here, but it's still balanced. You want to make sure that the counterweight also does not swing heavily down. So, if this is imbalanced, or not in balance, I should say, and one of these things become loose, what's going to happen is this counterweight's going to drop really quick. And it's pretty heavy. This would hurt someone very, very much if it hit them on the head. Probably crack their skull. So we need to make sure that this is all in balance. Once it's in balance, we lock it in place, both angle-wise and lengthwise. Now we need to attach a microphone, because by attaching a microphone at this end of the Starbird stand, it's going to change my weight distribution. Obviously, the microphone is going to add weight as well as maybe some length, and it's going to push it down. So for this, I'm going to use the heaviest microphone that we have, which is the Coles 4038. This is its mic clip, and this is the actual microphone. It's a pretty heavy magnet inside there. But again, always set your microphones aside and put your clip on first. Threading the wrong way because I'm smart. I'm doing this all backwards today. And there we go. And now I'm going to attach the microphone to its clip. And watch how this weight distribution is going to change when I let go. Now it's all locked and tight back there. So I don't have to worry about it falling, but I want to be aware. So I have that attached. Now I'm going to let go of the microphone. Look at that weight distribution change and how it's sunk. So now I know that when I loosen this angle, that weight is now going down there. So I have to push back this way and rebalance the stand. So let's see how far I have to go back for it to be back in balance. So now we're counter in balance back there. And now my balance, I'm fully loose on my angle. I'm fully loose up here, but I'm going to tighten this down now. So now my length is tightened and set. And now when I place my microphone, if it were to be knocked, it would drop slowly in either direction. And that's what you want. You don't want it to drop suddenly. And so once you set your microphone position, you lock it in place, and you're done with your setup of your starboard stand. Now, when the starboard stand needs to be taken down, the first thing you do is remove the mic. So let's drop this. We'll remove the mic, put the expensive mic back someplace safe in its case or off to the side. We'll remove the clip. Complete with all squeaks. Set that in its case. And now we drop this back. Again, it's going to be in balance, so you want to keep an eye on it. We always want the counterweight towards the bottom of the stand, and we drop the full extension of the boom arm down, and we lightly tighten everything just to make sure it doesn't have to be clamped down in this position. We lightly tighten it down and make sure it's fully set. And now we can unlock the wheels and put it back into storage. And that's how you use a starboard stand and balance a starboard stand. All right, so now we're going to discuss a tube microphone. And what we have right now is a U87 made by Neumann. It's a pretty famous tube microphone, used a lot for vocals and acoustic guitar. Beatles used one, I've used one, so, you know, they're legendary. Why are we discussing tube microphones and tube condensers specifically? Well, they're a little bit different than traditional condenser microphones. Condenser microphones need power to operate. Tube condensers also do. But with traditional condenser microphones, we can just use 48 volts or phantom power. With tube microphones, we have to use a separate power supply or a power supply unit. And that's because the tube that's inside the microphone or inside the power supply unit needs more voltage. Why do we use tubes? Because they sound warmer. They're going to give a kind of a vintage sound. They're going to give a little bit more harmonic saturation, which is something that we generally enjoy as humans when we listen to music. The big thing to know about tube microphones is that they're going to come with their own cable. So this is a cable that is made specifically for the U67. Not all tube mic cables are the same, so you can't really use them interchangeably between units. So on the power supply, you want to make sure that your power is off before connecting the microphone. Now we're going to connect the cable. We're going to insert it and screw it in. You need to make sure that is a solid connection. We're going to take the other end, put it into the top of the tube microphone. There we go. Screw that in to the base. And now that everything's connected, we turn on our power supply. Turn it on, light comes on. That means it's getting power. We're going to give this a few minutes to warm up before we use the microphone. We're just going to let the tube acclimate to its new voltage. Once the tube is warmed up, we can use the microphone. We can set it to record. We can use whatever we need. Now, at the end of the session, we are going to tear down this microphone. And the first step is, of course, to what? Turn off the power. So we need to turn this off first, turn off the power. And I like to give this, a few minutes to cool down, essentially. So while this is powering down, I'm going to go take down some other microphones, maybe help the guitarist pack up, maybe help the drummer put their cymbals away. When a few minutes have passed, I'm going to come back over and I'm going to unplug the microphone. So we start by unplugging at the power supply, and then unplugging at the microphone. And then when everything is ready to go, we put it away in the box for safekeeping, and that's the proper care and use of a tube microphone. Bye. Goodbye. Bye. What is wrong with this picture? Say I'm a musician or a voiceover actor or something like that, and I have music in front of me, I have words in front of me that I have to read. What is obstructing me from reading those and doing that properly? The microphone itself. It's actually not in a bad place as far as capturing my voice, but the basket itself, the shock mount that is holding the microphone, is obstructing my point of view. Okay, well, this is a simple fix, right? Let's extend this out and flip it over. So we can now flip this over. But wait a second. What's happening here? Now it's angled at the sky. It's not at my voice. I can't angle it any more down. Okay, well, maybe I can extend the boom in some weird way, right? I can come in like this, right? To make it a little bit better. And that's kind of works. We've solved the problem, but now I have the boom is going up. We don't want that. It doesn't look good. It's not professional. It's out of balance. The microphone is obviously weighted this way now. There's no counterbalance on the back end. So how do we fix this? Well, we need to flip the basket. So now we're going to remove the basket. What we need to do is we need to take this inner basket and flip it so it's upside down. We're going to keep this outer ring of the shock mount on the ground or on the table. So we're going to remove all of these supports, and they're kind of going to come off, and this can be always kind of frustrating, and the more and more you do this, the better you will get at it. But you can see now these little rubber bands, or whatever you want to call them, elastic bands, kind of come off. And so now we can remove that center basket, and we're going to flip this other ring the other way. We haven't changed the orientation of that one. We're going to change the orientation of this one. We're going to push those down, and we're going to put the elastic bands inside, and we're going to push this down, and we're going to start connecting the other side. And so we can flip this now, keep the pressure on so that bottom elastic band doesn't come loose, and we can push that in there. Let's go put it back over on the mic stand. So if I put this now on the mic stand, we can see that our problem from before is solved. I can now have the boom arm angled downward. I can put my microphone back in. And the mic is hanging perfectly. I can see all of my music. I can see the words that I'm going to read. The shock mount is not in the way. The basket's not in the way. The microphone's not in the way. We have a nice look to the arm of the microphone stand. It's angled downwards. The actual microphone looks good. So changing the orientation of the basket can be done. It's very easy to do. If you find that your basket has disconnected from the elastic bands and you open it up, don't put the microphone back, fix it, and then move forward. So that's how you change the basket on a shock mount. Buttons, knobs, buttons. There's a lot. They call it a bus. It's an old electrical term where things are bussed together. So think about it as an actual bus, like a transportation bus. So you're going to put a whole bunch of people on a vehicle and you're going to get them through one route to a similar place. That's exactly what's happening here electronically. We want to send all our signals on one route to the same path.